So let's take an example to understand how this partition affects table performance. All right, so we have a table with a provisioned capacity of 500 RCUs and 500 WCUs, all right? And our storage requirements are under 10 gigs. So let's calculate the number of partitions. So number of partitions based on throughput would be something like this: 500 RCUs by 3000 plus 500 WCUs by 1000. So that comes to about 0.67, and when you round it up, you get about one partition. All right, so our data can be stored in a single partition and it can deliver us the required throughput of 500 WCUs and 500 RCUs. But now let's say we scale up this table with a new provisioned capacity and we set the table capacity at 1000 RCUs and 1000 WCUs. Now what would be the new number of partitions? Let's see. So 1000 by 3000 plus 1000 by 1000. So that comes to around 1.33. So that will result in 2 partitions. So DynamoDB is going to create 2 new partitions and segregate data into it. So each partition will receive equal amount of new provisioned capacity. So half of RCUs will go to each table and half of WCUs will go to each table. So each table is going to receive 500 RCUs and 500 WCUs. So when you scale up, you're going to increase the number of partitions. So remember that when you scale up the capacity, you might end up increasing the number of partitions that get allocated to your table. Now let's see what happens when you scale up the storage. Okay, so we have provisioned capacity of 1000 RCUs and 500 WCUs as an example, and your storage requirement currently is 5 gigs. So the number of partitions based on throughput would be 0.67 and rounded up will be 1 partition. And let's calculate based on size. So you divide the available storage size by 10 gigs. So you get about 0.5. Again, with storage also you need about 1 partition. So final number of partitions that you need is maximum of the 2 values. 1 or 1 will be 1. So with 5 gigs of storage and with 1000 RCUs and 500 WCUs, you're going to need about 1 partition. Now let's say we scale up the storage and new storage size is about 50 gigs. Now again, let's calculate the number of partitions. Partitions based on throughput remain the same because we have not changed the provision capacity, and partitions based on size will now be about 5 because we have increased the storage size to 50 GB. So 50 gigs by 10 gives us 5. So maximum of 1 and 5 is 5. So total number of partitions now will be 5. So your table will now have 5 different partitions. So you'll have it like this, and each partition is going to receive a fifth of the provision capacity. And now this is very, very important to note. So now each table is going to receive about 200 RCUs and 100 WCUs. So do you notice that? So now your table is going to perform much lower than what it used to perform before. So to get the same level of performance, you'll have to increase the provision capacity about 5 times. And that also means that you'll be increasing your costs about 5 times. Again, if we now increase the storage size to 500 GB, now that's going to result in a massive increase in number of partitions. You're going to need about 50 partitions, and now each partition is going to receive just about 20 RCUs and 10 WCUs. That's about 1/50th of the provisioned capacity. So look, if you want to get a performance throughput of 1000 RCUs and 500 WCUs, then you will have to increase the provisioned capacity by 50 times. So it comes to somewhere around 50,000 RCUs and 25,000 WCUs. So partition behavior is very important to understand, and remember that once you increase the number of partitions, once you increase the number of allocated physical partitions, they will not be deallocated again. And if you want them to be deallocated, then you have to create a new DynamoDB table.